Hello students, today we are going to see the extension of the previous topic, the effect of electromagnetic fields. Actually, the effect of electromagnetic field is not a new phenomena. Due to the creation of more and more artificial sources, every human being is exposed to a complex mix of weak electric and magnetic signals, both at the home as well as at the workplace. From generation, transmission of electricity, even domestic appliances, industrial equipment, telecommunication, broadcasting, all these are sources for electric and magnetic fields. Tiny electric current always present inside the human body. This tiny current is due to the chemical reactions that occurs in the part of the body for normal functions, even in the absence of electric field. So those signals are the relay signals. Now, we all know this because in our human body there will be numerous electrical signals will be present. These electrical signals will be generated at the brain and it is transmitted to each and every organ of the body. Depending upon the intensity and duration, the particular body will function. So these electrical signals are produced by chemical reactions occurred in the human body, and these signals are present inside without any external applied field. So low frequency electric field influence the human body, influence the electric charges at their surface. They cause current to flow through the body to the ground. This low frequency electric field is a external electric field. It will influence our body, and so the distribution charges will be reoriented. Due to this reorientation, the current will start to flow on the body. Likewise, say a magnetic field low frequency will also induce circulating current within the human body. These current would cause stimulation of nerves and muscles and affect the biological process. Both these electric and magnetic fields induce voltages and currents in the body, but even directly beneath at a high voltage transmission, the induced current very small compared to the thresholds of producing shock and other electrical effects. So you can understand in this diagram. So here a person is standing away from the. This person is standing away from the tower. Now he is not standing directly beneath the transmission line. So there is no electric field or magnetic field acting on him. If you look at here, he is directly standing beneath the transmission line. Due to this transmission line, there is a low frequency electric field and magnetic field will happen to affect the human body. Due to this low electric field and magnetic field, there will be induced voltage and current. This induced voltage current in the human body will be very small and it will be a threshold. It will be below the threshold. If it is below the threshold value, there will be no problem for him. So the structures will be designed such that these electric field or magnetic field will be kept at a very low permissible value. Okay. So he will not be he will not be experience any shock. You can understand whether you feel shock or not, you are going to get exposed to the electric field and magnetic. This is the truth here. So what will be the effect? Radio frequency field. And due to the radio frequency range frequency, heating is the main biological effect. Heating is the main biological effect. Scientists also investigating the possibility of the effects below the threshold value for body heating as a result of the long-term exposure. Even though the produced value is very low, this is very low, not going to harm anything. If he is exposed to a very long time, then definitely heating is going to happen. The radio frequency field means it is the field where the frequency is involved between 10 megahertz to 300 gigahertz. Due to this long exposure, heating will happen. Due to the heating, genotoxic. Genotoxic means DNA will damage, cancer may come, and that is the leukemia. Central nervous system, cognitive function, always feeling sleep like that, we get the ailment, impairment of well-being, headache, hypersensitivity, blood-brain barrier. Likewise, effect will happen inside the human body. So next thing will be the review of vector calculus. For studying the electromagnetic field theory subject, we need the mathematics of vector calculus, which is very much important because it will be very easy to solve. If you look into the vector calculus, it will be very easy to solve the electromagnetic theory. So before starting implementing this vector calculus, let us review this theory first. So the vector calculus, as the word mentioned vector, it has both magnitude as well as direction. So we know two quantities are there. One is the scalar quantity, another one is a vector quantity. The scalar quantity is a thing which has only magnitude, no direction. You can say, for example, mass, speed, area, work. Whereas vector, it has both magnitude as well as direction, and maybe velocity, weight, and acceleration. So basic laws for vector algebra, we should know what is addition, what is subtraction, what is multiplication, like this. So vector A can be written in terms of Cartesian unit, x vector, y vector, and z vector. You can see here there are three axes, x axis, y axis, and z axis. So the corresponding vectors here will be A, x vector, x cap. This will be y cap and z cap. In some literature, they used to use the letter I vector, j vector, and k vector. You can follow any one of these, but you must be very strong. You should not get confused. So you can write this vector as a vector equal to ax x cap plus ay into y vector plus az into z vector. What is ax, ay, and az? It is the component present along the x-axis, y-axis, and z-axis respectively. You can see here, this is the a vector. So this a vector has x component, y component, and z component. Its x component is ax, its y component is ay, and this one is az. All three axes are acting perpendicular to each other. So when we can say they are mutually perpendicular to each other. You can find out the magnitude or length of this a vector by square root of x component, which is ax square, plus y component ay square, plus az square. How to find the direction of it? It is neither along x-axis, nor along y-axis, nor along z-axis. Not going parallel with any of the three axes or perpendicular to any of the three axes. It has some other direction. So how to find the direction is given by vector A divided by modulus vector. This unit vector, vector A divided by modulus vector. You know the vector quantity divided by the modulus vector. This is the unit vector acting along the A vector. How to do subtraction in addition and addition in vector. So there are two laws used here. One is parallelogram law and one is triangle law. So parallelogram. So if you want to add a vector and b vector, see here OA represents a vector and OB represents b vector. How to find the addition of two vectors? So b vector can be taken parallel here. OB can be represented here as AC and BC is represented from OA. Both are BC and OA are parallel. Similarly, AC is parallel with OB. So if it is B, it is also B vector. It is A vector, so it is also an A vector. So any one of the diagonal will do A vector plus B vector. So because A vector plus B vector equals this diagonal. So this is known as parallelogram. We have to unnecessarily draw two vectors here, C, A, C, and B. So why should we bother? So what we have to do is to go with the triangle. So here the two vectors are started at the same point. Here from O only taken A vector, from O only taken B vector. Here it is not so. Along AB take one vector. At the end of the first vector take the next vector. The addition of these two will give the resultant vector. If it is A, it is B, then this one will be A plus B. So A, B. So here we can, and one more inference we have to see here is A, B is going in this direction, then B, C is also going in our direction. But if you look into C, A, it is in opposite direction of our travel. So the resultant will be in the opposite direction of the travel. So A plus B will be equal to so AC will be equal to A vector plus B vector. So to define the subtraction, what we should do is we can easily do if you want to do A vector minus B vector, then what you should do A vector plus minus of B vector. Instead of drawing vector in the vector, for easy thing I have marked and underlined here A vector plus minus of B vector. You change the direction of B vector, then add this minus B vector with the original vector. See here it is A vector. How should we represent minus A vector? So we just change the direction, it will look as minus A vector. So now I want to do A minus B means A vector here. So A vector I have not changed the direction, it is taken as the same direction. So B vector here, but now what should I do? I have to add minus B vector to A. So this one is A vector, this one B means minus B opposite direction. So minus B. Now the resultant this will be A minus B will be represented here. So addition and subtraction, it will obey two laws. One is commutative and associative law. Commutative law, the two vectors are involved A and B, and for associative A, B, C, three vectors are involved. A plus B will be equal to B plus A plus B plus C. So what we will do first is perform the things which are inside the bracket, which is B plus C. Then A is added with B plus C. So here if you add A plus B first, then add the resultant to C vector, you get the same answer. So vector addition always obey commutative and associative law. So what are the components of a vector? It has magnitude and direction. So this one is the A vector. You can see here. It has two components, X component and Y vector. So the angle between the vector and the X direction is phi. So you can say from this you can find Ax is the X component of A vector and Ay is the Y component of A vector. How to find Ax? You can say cos pi equal to adjacent by hypotenuse. Cos pi is equal to Ax by A vector. So sin pi is equal to this one Ay by A vector. So in other words, Ax is equal to A cos pi, Ay is equal to A sin pi. So you can find easily, if you are able to draw the vector, you can easily find out its X component and Y component using the trigonometric relations. So next class we have to see the multiplication, which is the prime important for this electromagnetic theory. There are 4 multiplications. You can see one by one in detail in the next video. If you have any doubt, you can ask me. Have a nice day. Thank you.